Okay, we're going to do a couple of problems here that have to do with the continuity of functions. In this one, it says find the constants a and b so that the function is continuous on the entire real line, and then they give you this three-chunk piecewise function. F of x equals 8 when x is less than or equal to negative 2. It equals this formula, ax plus b, so that's what we're going to have to find out when it's between negative 2 and 3, and f of x equals negative 17 when x is greater than or equal to 3. So I think the best way to visualize how to make this function continuous is to plot these two branches that are pretty easy for us. So let's see, I'm going to make each box worth 2. So here's a negative 2 and 2, 4, 6, 8. So there's negative 2, 8, and all the way this way the function is 8. Okay, that's what that first part says. And then we've got f of x equals negative 17 when x is greater than or equal to 3. So there's 3 and 2, 4, 6, 8, 10, 12, 14, 16, 17. So about right there, whoops, right there, and heading this way. So those are the two arms we know. Now to make this function continuous, that is to go on without a break, we simply connect the dots, really. And it's that line that goes in between the two that we want to find the formula for. Okay? Now if I had drawn this really neatly and had fine graph paper, I could probably figure out the slope and the intercept and figure out the formula for that line from just looking at it, but I didn't do it that neatly. So I'm going to use the point slope form. And I have 2 points that I know are in this line. One of them is right here. That is the point negative 2, comma 8. And right here, that point is 3, comma negative 17. Now, from those 2 points, I can figure out the slope. Slope is rise over run. So I'm going to look at the difference between the y-coordinates to get rise. We go from 8 all the way down to negative 17. That's minus 25. And then we go from negative 2 over to 3. That's a positive 5. So our slope equals negative 5. And now, our point slope form is y minus y1 equals slope times x minus x1. So, and I'll just take the point negative 2, 8 to plug in there. And our slope we know is 5. So y minus 8 equals the slope, which is negative 5, times x minus a negative 2, so that's plus 2. And then we do the algebra here, so that's negative 5x minus 10 equals y minus 8. We add 8 to each side, and we get y equals negative 5x minus 2. So when we go back to our original formula up here, this a, that's our negative 5, and b, that's our negative 2, and that is our answer. And this problem is fairly similar to the last one. We're given a piecewise function here, and we want to find the value of, actually this is wrong, we want to find a so that the function is continuous on the entire real line. So in this case, there's a little trick to do with algebra first. This x squared minus a squared over x minus a looks a little bit complicated, but you should notice that the top is a difference of squares. So x squared minus a squared equals x minus a times x plus a. Now that is all over x minus a, so the x minus a's can cancel, and you really get f of x equals x plus a. Now, this function is 4 when x equals a. So I can simply rewrite this equation and set it equal to 4 when x equals a. If I do that, 4, f of x is 4 when x plus a, well, x is a, so that would just be a plus a. And we get a very simple formula here. 4 equals 2a, and a equals 2. So, didn't even really have to graph this one. If you look at it, it's going to be a straight line here, and it's going to go through the point 2, 4. So let's see, 2, 4. It's going to look something like that. And that's how you do that one.